Welcome to the worst 3D printer I ever owned. This is it, the Leapfrog Creator. Now, what made it crap? I'll tell you. So, first and most crap, the extruders. This was originally a dual extruder 3D printer, and I ended up replacing the dual extruders with a single bulldog extruder. And the reason that I did that was because the original ones were so unreliable. And that's a word of warning I've got for any prospective 3D printer builders out there, or makers or manufacturers, and that is, get your extruder right first. Forget the rest of the machine, forget all the doodads and the self-leveling and all that bullshit. Get the extruder right. A crappy extruder equals a crappy 3D printer every time. And this thing drove me nuts. It was my first 3D printer that I ever bought. I paid $3,500 Australian for this machine and imported it from the Netherlands at not inconsiderable expense. And I went for it. I'm perfectly willing to admit I went for it because it was the biggest machine that you could get at the time. It had the biggest print bed at the time that you could get. And, I jumped in the deep end. And, I bought this machine because on the surface it looked like it was really well engineered. I really liked some of the features that it had. I liked the fact that they used a lot of laser cut components here, like this platform that the extruder's on. That's all laser cut. Honestly, there's just so many things that was wrong with this machine from the get-go. So let's have a look at a few of the features. So every time something went wrong with the extruders on this machine, I had to dismantle this entire carriage, which also meant taking the clamps off this belt. So every time I had to fix it and put it back together, I had to take off these belts, and the gods are not smiling upon me. Maybe this is the right size. A miracle has occurred. Okay, so this was the routine. Take these off, and of course these are steel fasteners into just soft aluminium plate. So as time went by, these, look, there's some thread come out there with that one. So as time went by, the thread started to chop out on these, and I'm going to be careful with this because I do need to reuse these components. So I'm not really happy that some thread came out with that screw. So we would take this apart. So walk down memory lane, and so belt would come out. Then to get to the extruders, I would need to dismantle this front plate, which has some big ass screws that go all the way back to another plate back here, which just fell out. Okay, so I had that. Then we had this. Now, I ended up putting an E3D on this. This is one of the early-ish E3D extruders, and the bulldog, obviously, as you can see. So another thing that happened was that the sleeve bearings here were just pressed into these plates, and as time went by, they loosened up and just ran freely, and like, man, they're crusty now. And that just attached from there was running up and down, so I actually glued it back in, which I'm not proud about. Some of the other components that were here were these little shields that I forget where they were, whether they were in front of the stepper motors or in front of the, they were in front of the stepper motors. So when you went to dismantle this thing, it just basically fell apart in your hands. Okay, here's another bit of brilliance on the Leapfrog. was this top cover. Now, the wow, didn't know there's some filament in there. The extruders were direct drive, so they would draw the filament up from down here, up a tube, Teflon tube, and that would go into the extruders. And now, every time the extruders and their wiring and the filament tubes, because there was 2 of them, every time they went back to that end, they went underneath this back edge here, which would push down on the filament tubes and make it just that much more difficult for the machine to pull the filament up. It was already having problems, but this just added another layer of difficulty to the whole thing. The forum for these printers was an absolute laugh. There was just people on there going, oh, you know, I've bought a $3,500 doorstop, you know, or a paperweight or a boat anchor or whatever. And you know who you never saw on the forums was any of the guys that were connected with building these things. And then when the number of dissenting and outraged voices got too much for them, they just vaporized it. They vaporized the whole forum and all the posts on it and all the knowledge that people had put on there. I was trying to help people out. People were trying to help me out. You know, we were exchanging knowledge as you do on those forums, and they just, see you later, you know, didn't like all the negative press. So, unfortunately I don't have the extruder to show you, but I might do a little sketch of what it looked like and what its main deficiency was. So I managed to find a close-up picture of the original extruders fully assembled, and I'll just walk you through the features here. Okay, so here's the clamps that hold the belts on, and this set screw and this set screw basically hold the whole thing together. Once you take those 2 out, a plate falls down from behind here, and then the fans are loose, and then you've just got the stepper motors and these little shields, which you can just see here, the shield, which is on the front of the stepper motor, and I've no idea why they were ever there. They didn't seem to perform any kind of useful function. Behind there is the stepper motor, obviously, and this is fitted with an action chain up here, which my machine never had. On my machine, the wiring loom used to drag along the print bed, and sometimes it would snap the print off the bed. And we all know how difficult it is to achieve adhesion with a 3D print, but here we had the machine fighting you. Yes, it would rip the print off the bed on its own. Now we go to a close-up of the NEMA 17 stepper motor, and you can see here now how the filament feed was arranged. You've got the hobbed wheel here, and then a plain bearing here that was meant to keep tension on the filament coming down here. Now these are disassembled because this is the way it always looked when you disassembled it, because you took the cap screws out of here and then the motor was loose, and as you can see it's not lined up with the top of the feed tube. It didn't look like this when it was assembled. However, you can perceive the distance here between where the fed filament came out and went down this tube, and you can see that because it's got this little chamfer in the top of it, this is like an unsupported length of probably about, I don't know, 6 millimeters, which meant it was very easy for filament to just spool right out, and so it would miss the top of the feed tube and it would go around here and it would do this sort of thing, which was great fun. So the other big deficit here is that there's no spring tension here. This needs to be spring tense in this area here to clamp the filament. all you need is undersized filament to be put in here, and all of a sudden this arrangement, which is statically set up, will lose pressure and will stop feeding the filament. Drive you absolutely mental. The next one here is the dual extruders. Sorry about the resolution of this picture, but this was the dual extruders. As you can see, they're a mirror image, and there's the top of the feed tube there and there, and you know, that's how that was set up. And the last one here is the underside, and these connectors, and the ones that were associated with heaters in particular were problematic because they were passing a lot of current and they got all crispy, didn't they? So they had to be replaced and so forth. But you can see here, that's the front plate with the fans on it, that's the shield plate there, shield there, and so forth. So this was a really multi-part assembly that you had to take completely to bits just to get to this area here, which is where everything went wrong. It was so frustrating. Here we are at the front of the machine. Okay, and here is a genius idea. These little kind of turntable-y things, all right? So what was meant to happen there? You got your filament reel, and it went on there, and it turned around, which was fine in concept. But when the reel was full, this one is not, when the reel was full, you lay it down on its side, and as soon as a little bit of tension goes off the packed up filament, it just all falls off. So you basically had a massive, you know, potential tangle under here. You went every time you went to start off a print, you had to come down here and you had to spool the plastic back onto the reel, and then you poke it through this little hole here, and the little hole originally had a burr on it, so as the plastic was going through here, so it shaved off some plastic and made the filament thinner, which just improved the dodgy flipping extruders just that much more. That's exactly what they needed. You know, they hardly had any tension built into them mechanically, and running a filament that was even smaller than it was when it started out really helped things along. Not! Okay, next time I'm going to do a teardown on this machine, and we're going to have a look at some of the crusty old components that they used to make it. And then in another show, I'm going to convert this into a laser cutter. That should be fun. Well, thanks for watching, and don't forget to like and subscribe if you enjoyed the video. And now it's time for my sign off. Onward and upward.